Now we will do some exercises on annuities. In this exercise, we will calculate the value of an annuity and calculate the payment needed to achieve a determined future value. To calculate the value of an annuity, we will use the following formula here. P sub n is the balance of the annuity after n years, or the value of the annuity after certain period of time. And D is the regular deposit, or the monthly payment, the quarterly payment, the semi-annual payment, etc. And R here is the annual interest rate, and this should be written in decimal. K is the number of compounding periods in 1 year. K is equal to 12 if it is monthly, and K is equal to 4 if it is quarterly, and K is equal to 2 if it is semi-annually, and K is equal to 1 if it is annually, and K is equal to 365 if it is daily. Now let us consider this exercise. Calculate the value of an annuity given the following scenario, and then calculate the total amount invested and the interest earned, and then round the answer to the nearest tenth if necessary. So in this case, we are given a deposit of $175 made quarterly and the interest rate of 2.5% for 15 years. So to calculate the value of the annuity after 15 years, let us first identify the following information, or the given information here. This 175 is the deposit, so D is equal to $175. And this is done quarterly. So therefore, the compounder, the number of compounding period is equal to 4. So K is equal to 4. The interest rate is 2.5%. R, therefore, in decimal is 0.025. And then the 15 here is the number of years, and capital N is equal to 15. So in our formula, which is P sub n, that's the amount or the value of an annuity after n years, equal to D, this is the deposit made quarterly in this case, times 1 plus R, which is the rate of interest, over K, number of compounding periods, times N, which is the number of years, times K again, which is number of compounding periods, minus 1, quantity, divided by R over K. So let's just plug in the information here to the formula. D is given by 175. So we have 175 times 1 plus our rate is 0.025. So 0.025. And then K, the number of compounding periods is 4 because this is done quarterly. So K is equal to 4 raised to N, which is the number of years. So capital N is 15. So 15 times 4 minus 1 all over 0.025 over 4. And then you plug this into your calculator. You make sure you plug this in correctly. I suggest you use the online calculator that will be available to you during your test, which is the ClassCalc. So you make sure you enter it properly. If you want to have this fraction here, you just have to press division. So you plug in your formula into your calculator as how you see it, and then this is the answer. So this is the amount or the value of the annuity after 15 years. That is 12,692.24243. But we are asked to round it off to the nearest cent. Nearest cent, that means 2 decimal places. So that gives us 12,692.24. So we have just calculated the value of the annuity here, and the value is given by $12,692.24. Now, we want to calculate the total amount invested and the interest earned. To calculate the total amount invested, we are just going to multiply the amount of deposit by the number of times the deposit is made in a year and the number of years. So in this case, the total amount of invested is 175 times 4 because the deposit is made quarterly, times 15 because we have 15 years. Multiplying 175 and 4 and 15 will give you $10,500. So $10,500 is the total amount of invested. Then next, we will calculate the amount of interest earned. The amount of interest earned is calculated by subtracting the value of an annuity and the total amount invested. So the interest earned is just the value of an annuity minus the total amount invested. With that, the value of an annuity in this case is $12,692.24 minus the total amount invested, which is $10,500. Calculating this or plugging this into your calculator, you get $2,192.24. So that means 2,192.24 is the total interest earned. Example number 2. Calculate the value of an annuity given the following scenario. Then calculate the total amount invested and the interest earned. Then round your answer to the nearest cent if necessary. In this case, the amount of deposit is $200 and this is made monthly. And the interest rate is 4.7% for 20 years. So if the deposit is $200, that would mean D in your formula is equal to 200. And since this is done monthly, so the number of compounding periods K is equal to 12. And the interest rate is 4.7%. That means the R in decimal is equal to 0.047. And then the 20 years here is the number of years. That's capital N. N is equal to 20. So then you use the formula, you plug it into your formula for P sub N. That is equal to D, in this case is 200 times quantity, 1 plus R, our rate is 0.047 divided by the number of compounding periods, in this case it's 12 over K, and raised to the number of years, which is 20, times the number of compounding periods, which is 12, minus 1, then close parenthesis, all over R over K, so 0.047 over 12. And then you plug this into your calculator. So let's go ahead and plug this into a class calc. This is the calculator that will be available to you during your test. So 200 times quantity 1 plus 0.047, that's the rate, divided by the number of compounding periods, which is 12, parenthesis, raise this to, so this is for the exponent, 20 times, that's a number of years, times the compounding period, which is 12. Then in the middle, minus 1. The whole thing here is our denominator. So let's put a parenthesis for that here. And then divided by 0.047 divided by 12. And that gives us 79,418.83 cents. And so the value of the annuity after 20 years is 79,418.83 cents. Next, we will then calculate the total amount invested. So to calculate the total amount invested, we will just going to multiply the amount of deposit D times the number of compounding periods K times the number of years. So in this case, we have 200. That is the amount of deposit, and this is made monthly. So K is equal to 12 times the number of years. So that is for 20 years. So times 20. Multiplying everything together, we have 48,000. So 48,000 is the total amount invested. This is the total amount invested in the annuity. Next, let's calculate the interest earned. So to calculate the interest earned, all you need to do is subtract the value of the annuity, the total amount or value in the annuity after 20 years, and the total amount of investment or the total amount invested. So that is 79,418.83 minus 48,000. And this is equal to 31,509.72. So the total interest earned is $31,509.72. Okay, another example. We are going to calculate the value of an annuity and then calculate the total amount invested and the interest earned, and then round off the answer to the nearest cent if necessary. In this case, the deposit is $135 and this is made semi-annually. The interest rate is 3.9% for 25 years. So the deposit of $135, that means D is equal to 135. Semi-annually, that means K is equal to 2. That's twice a year. And interest rate R in decimal is equal to 0.039. And then this is N, capital N, so that is 25. Then you plug it into your formula for P sub n, and you're able to calculate P sub n as 135, that's your D, quantity 1 plus R, 0.039 divided by 2, number of compounding periods, raised to number of years, in this case 25, times the number of compounding period, which is 2, minus 1. All over 0.039 divided by 2. Then you plug this into your calculator. You have to be very careful. And then you will get 11,259.72 cents. That is the value of an annuity for after 25 years. And then we will calculate the total amount of investment or the total amount invested. So the total amount invested is calculated by multiplying D, the deposit, times the number of compounding periods times the number of years. So we have 135 here times 2 times the number of years, which is 25. So 35 times 2 times 25 is equal to $6,750. That is the total amount invested. Now, to get the interest earned, we are going to calculate the amount of the annuity, the value of the annuity, and then subtract that by the amount of investment or the amount invested. So it's 11,259.72 minus the amount invested, which is 6,750.00. Subtracting these two will give us $4,509.72. That is the total interest earned.